Hi and welcome. So last time in class, we learned that the derivative of the natural logarithm of x was 1 over x, and that the slightly more general version of the ln of x is also 1 over x. Here, the only difference is that this only applies for x greater than 0, whereas this applies for any x not equal to 0. But I'll just box this main part. That's really the key point that we're going to use today. And so let's just work an example. So suppose that y is this x times ln of x, and you're asked to find y prime. Okay. Well, we'll just write this as the product rule f of x times g of x. Then we're just going to use the product rule of f prime of x times by g of x plus f of x times by g prime of x. Okay, so we better write down f of x and g of x. Okay, f of x is going to be x, so f prime of x is 1. G of x is this ln of x, so g prime of x is going to be 1 over x. Okay, and so now we get 1 times ln of x plus x times by 1 over x. Okay, so that'll be ln of x plus 1, and that's the derivative. Okay. Let's work another quick example here. Suppose y is going to be equal to this sine of e to the x plus ln of x. Well, in this case, this is going to be a composite. This is f of g of x. Okay, so to find y prime is just going to be f prime of g of x times by g prime of x. So here, f of x is going to be the sine of x, and f prime of x, that's going to be the cosine. G of x is everything inside sine, so it'll be x plus ln of x. Derivative of e to the x will be e to the x itself. Okay, so g prime is going to be e to the x. Derivative ln of x is 1 over x. Now using composition, I'm going to get cosine of e to the x plus ln of x multiplied by the derivative of the inside, which is e to the x plus 1 over x. Okay. Now we're going to talk about something called logarithmic differentiation. Okay. Logarithmic differentiation, the first example we're going to have is y is going to be 2 to the x. We know the derivative of e to the x is e to the x, but that's base e. In this example, we have base 2. So what we do here is we take the log of both sides. Now, this gives us ln of y is equal to ln of 2 to the x. Now, by properties of logarithms, I can bring the exponent out in front. That's x times ln of 2. Apply differentiation. Okay, so apply d by dx. And I'm going to have d over dx of ln of y is equal to x times this ln of 2. Okay. Derivative of x is 1, so I'm just going to have 1 times ln of 2 as a constant. On the left-hand side, the derivative ln is 1 over y, but remember I have to multiply by the derivative of the inside. Well, and what's inside is y. The derivative of y is called y prime. So if I solve for y prime, that is, I get y times by ln of 2. My goal is to have my final answer in terms of x alone. Remember, y is 2 to the x. Okay? And so the derivative of 2 to the x is 2 to the x times ln of 2. Okay? That was an example of logarithmic differentiation. Let's do another example. Suppose I have y is going to be x to the power sine of x. We're going to take the same steps. So we're going to take ln of y as this ln of x times by sine of x. Okay. Now I can use the properties of exponents, and I can get sine of x times by ln of x. Apply differentiation. So I differentiate each side, and I get ln of y is equal to sine of x times by this ln of x. Just as before, I differentiate ln of y, I get 1 over y times the derivative of the inside, that's y prime. On the right-hand side, I need to do the product rule. Okay, so product rule will say differentiate sine, that'll give me cosine, leave ln of x alone. For the next term, I leave sine of x alone, and I multiply by the derivative of ln, that's 1 over x. So this tells me, after solving for y prime, I get y times all this stuff. Cosine of x times by ln of x plus sine of x over x. Then just remember that y is x to the power of sine x. This is all going to be multiplied by cosine of x times by ln of x plus sine of x over x. And in this way, I'm able to find y prime. The key here is to take the logarithm, then apply differentiation. Before we apply differentiation, we'll typically use the rules of logarithms to move that exponent down. And in taking the logarithm, we'll also now have an implicit derivative. That is, when we just had ln of y, it was 1 over y times by y prime. Then we solve for y prime. In this instance, we got what was in this box. Thank you very much.